Hello, and welcome to another introductory segment for the OpenNEX Virtual Workshop in the year 2014. This lab will provide you with basic information on the NEX Downscaled Climate Projection Dataset, or NEX DCP30, noting the external references for more authoritative and detailed information. You will learn how to get started using the datasets by reading in a temporal subset from the NASA NEX S3 bucket, generate a simple set of figures using the subset, and then creating an animation from the figures. The intended audience for this segment is for those people that would like to have a very basic hands-on experience with the NEX DCP30 data. The dataset we'll be working with is comprised of statistically downscaled climate scenarios for the conterminous United States. The dataset is derived from the more coarse resolution general circulation model runs conducted under the Coupled Model Intercomparison Project Phase 5, or CMIP-5. For more detailed and authoritative information on this particular dataset and the topic in general, I would encourage you to check out the many available resources on the web. A few websites worth noting are the NASA's Center for Climate Simulation and the Program for Climate Modeled Diagnostics and Intercomparison, or PCMDI. The NEX DCP30 dataset also has an accompanying publication in the EOS Transactions American Geophysical Union's Journal in September 2013. The publication is titled Downscaled Climate Projections Suitable for Resource Management. While this data can be complex and intimidating for someone who is new to the topic, we are just going to read in a subset of the data from our NASA NEX S3 bucket, render a simple set of figures, and then animate them. The simple exercise in this lab will help you build confidence for more advanced labs where we will be applying other AWS cloud tools such as Elastic MapReduce to perform some simple operations on a much larger subset of the NEX DCP30 dataset. If you haven't already viewed the other introductory segments such as the AWS instance Hello World, please take a few minutes to view and digest that information now. As an aside, there are a few things worth mentioning about the instance types you as a user may choose to deploy for this lab. If your choice is to use something like the free tier micro instance, then you may have to wait a little longer for the example scripts to complete, as the micro instances are not really designed for data analytics on large data sets. If you would like to finish the lab a little bit faster, then it may be worth it for you to choose a more appropriate instance type, a larger compute container that will run this example AMI. So here I'll cut and paste my IP entry that I got from the EC2 Management Console. It's the IP of my newly launched instance. Okay, here we are. Let's change to the lab4 directory. And in here we see make simple animation.py, which is a very simple script written in the Python language. So let's open it up in our favorite Unix editor. You can see there isn't a whole lot in here, but let me just point a few things out. We are going to stage in the data from our NASA NEX S3 bucket. This is a netcdf file, and here's the kind of stage in directory. So staging a subset of the data, from our larger and sometimes slower S3 bucket to our kind of smaller and potentially faster block storage is a common pattern that a lot of people will employ prior to running various operations on a particular data set. So we stage in, and then we go up and we just create these figures. We iteratively call this routine, mask out some data, create some subplots, draw some boundaries and coastal lines, and then save the image. And then after we've done that for 12 images, we will make an animation. And the animation, we just use the open source tool Convert. So let's quit out of there, and then let's run the script. So now while this script is running, again, if you chose to use the smaller compute container, then you might want to go get a cup of coffee or something because it could take some time. But if you chose a larger compute container or larger instance type, then the script should execute a reasonable amount of time. So let's just wait for it to complete here. Okay, now we are building the animation with the convert utility. And that's it. We've created our figure set and our animation. And now let me bring up another terminal, and I am going to and now let me bring up another terminal, and I am going to and now let me bring up a local terminal, and I am going to SCP the figures we just created to my local system. And now let me bring up another local terminal, and I am going to SCP the remote files to my local desktop. Now you can choose, any kind of GUI-based secure copy program or something like that, but just to bring the files here so we can take a quick look. But in future upcoming labs, we will show you how to use the virtual network connection or VNC desktop. So in the future, you won't have to do this kind of copying. Let's get the animation. Take a quick look. Okay, and here is our figure we just created. So that completes our lab, and please come back and take a look at the other more advanced labs using this particular data set, and see you next time.